In the previous video lecture, we developed two general equations for calculating changes in entropy. And pinapakita ko sa inyo ngayon yung dalawang general equation na yon, which can be used for any kind of process and for any kind of gas, whether perfect gas or hindi. And the first equation stemmed from the fact na ang inyong entropy can be a function of both temperature and volume, while the other equation came from the fact that your entropy is a function of temperature and pressure. Hindi kasi natin pwedeng pag-isahin yung temperature, pressure, and volume. It's quite complicated. So we just develop two separate equations from both functions. But anyway, these two general equations can be used for a lot of problem types, and let's discuss one of them right now. So you have here an ideal gas undergoing an irreversible process from 200 degrees Celsius and 1 bar to 110 degrees Celsius and 10 bar. So the question is, what's the entropy change for 1 mole of the gas? So kung makikita nyo tong problem, meron ka ditong term na irreversible. Now, this word doesn't matter really kasi entropy is a state function. So, whether it's reversible or irreversible, walang problema. Now, another word or term that you have to take note here is that the gas is a perfect gas or ideal gas. Ibig sabihin, even if walang given dito na heat capacity value, we can assume that if we're going to assume na ang gas na to ay monoatomic gas. So, assume monoatomic gas. Okay, let me just probably put here that the gas is helium. Okay, now, if it's a monoatomic gas and it's a perfect gas, therefore, yung ating heat capacity can be, can have a value of 5 halves times R. Okay, yan yung ating heat capacity. Now, there are two kinds of changes or processes na nangyayari dito. Number one, there's a temperature change from 200 degrees Celsius to 110 degrees Celsius. And there's also a pressure change from 1 bar to 10 bar. So, ano kaya yung magiging entropy change natin for 1 mole of the gas? So, let's use these equations. And since mayroon tayong change in temperature and change in pressure, so maybe the second general equation is more applicable. So let me first copy this equation. Ito na yung equation natin. But since ideal gas ang meron tayo, we can actually reduce this equation further. Remember that for an ideal gas, this term here will be equal to 0. Okay, so what will be the reduced form of that equation? So magiging ds equals Cp over T dt plus, actually it's minus kasi meron tayong negative. So ituloy na natin, minus V over T dP. Now, since perfect gas ang meron tayo, we can express that yung volume as N RT over P. So we can substitute this volume dito sa volume na nasa equation natin. So magiging ds equals Cp over T dt minus nR over P dP. Na-cancel na kasi yung temperature natin. Now, merong given na moles or the amount of the gas, right? So actually, yung Cp natin, sabihin nating molar heat capacity yan. So we have to multiply pa by the number of moles so that we have a proper equation now. And what will happen next is we can now integrate this equation. Okay. Integrate all terms in the equation from condition 1 to condition 2. So, ang mangyayari is that yung ds natin magiging delta S na siya, which is what we're looking for. Equals N Cp molar, ibig sabihin naka per mole yung heat capacity, ln of T2 over T1 minus nr ln of P2 over P1. Now we can substitute the values that we have. So N is equal to 1 mole. Cp is, inassume natin na 5 halves R. So yung R natin is 8.314 joules per Kelvin mole. Ln of, ano yung mga temperature natin? So T2 is 110 degrees Celsius. 110 degrees Celsius, add to 273 kasi gusto natin absolute. And then 200 naman yung T1 natin. Minus N is 1 mole, R is still 8.314, ln of P2. So our final pressure is 10 and our initial is 1 bar. So 10 over 1. And you will be able to compute for the entropy change. Ang magiging sagot dyan is minus 25.5 joules per Kelvin. And since it's negative, this might be an unfavorable process. Kung sasabihin natin kung spontaneous or hindi, unfavorable siya. Now let's consider another problem, and here we want to calculate the entropy change when 2 moles of argon, walang sinabi kung ideal gas siya, are heated at constant volume from 300 Kelvin to 500 Kelvin. So you're given here the Cp equals 30 joules per Kelvin mole. So anong general equation kaya ang gagamitin natin? So magkakaroon tayo ng change in temperature, but meron tayo ditong constant volume. So pwedeng gamitin natin yung first general equation kasi both naman mayroong dt. So we can integrate to accept the change in temperature. But since constant volume siya, so malamang mayroong kang CV sa equation. Okay, and also since may dV or differential volume dun sa first general equation, we can just cancel that because constant volume na siya. Anyway, I'll just copy this equation. Eto na siya, and notice I changed the CV to CVM, meaning molar heat capacity yan. Okay, how do we reduce this general entropy equation? Since sinabi naman dito na constant volume yung ating process, we can just take the whole second term out. Tanggal yan lahat. Okay? So, ang matitira sa ating equation ay ds equals constant volume molar heat capacity over T dt. Now, walang sinabi doon sa problem na ideal gas siya or hindi. But assuming na hindi siya ideal gas, kasi kapag ideal gas yan, we can assume a value for your constant volume heat capacity. Anyway, given naman yung Cp, which is 30 joules per Kelvin mole. Pero we can probably still assume na perfect gas siya. And if we can do that, remember the relationship that Cp or the molar heat capacity constant pressure minus constant volume molar heat capacity is equal to R. Okay? Kasi CV yung meron sa ating final working equation, right? So we want to calculate the value for the constant volume heat capacity. So therefore, that will be CPM minus R. The value for CPM is given 30 joules per Kelvin mole. R is 8.314 joules per Kelvin mole. So, ang ending, yung CV natin will be 21.7 joules per Kelvin mole. And yan na yung pwede natin gamitin dito sa ating working equation. But we haven't integrated this equation. So let me do the integration. Integral from condition 1 to 2. So yung ds magiging delta S, change in entropy. Equals, ilang moles ba ang meron tayo? Anyway, ang magiging form ng equation is NCVM, constant kasi yan. We have the value. ln of T2 over T1. Okay, so N is 2 moles. CV is 21.7. ln of what's T2 and what's T1? 500 over 300. Is that right? Yes. So, let's do the calculation ng magiging delta S natin. We got here 22.2 joules per Kelvin mole. This is now our final answer for the change in entropy for this particular problem.